Hello everybody, welcome to your 8-1 lesson on right triangles and the Pythagorean theorem. Our learning target for this lesson, we are going to prove the Pythagorean theorem using similarity and establish the relationships in special right triangles. We will be able to understand and apply the relationships between side lengths in 45, 45, 90 and 30, 60, 90 triangles. All right, we have a little vocab to put in, and you guys know what the Pythagorean theorem is, but here's what it is more formally. If a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So, what we're saying is if we have a right triangle with side lengths A and B and hypotenuse C, then that means that the sum of the squares of the lengths, so if we square the lengths of the sides or of the legs, and we add those together, that is equal to the square of the length of the hypotenuse. So that's the formal way of saying A squared plus B squared equals C squared. All right, the converse of the Pythagorean theorem. If the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So, if we know that A squared plus B squared equals C squared, where C is the hypotenuse of your triangle, then we can conclude that triangle ABC is a right triangle. So Pythagorean theorem can work both ways. If you know that you have a right triangle first, then we know that this is true. If we know that this is true first, then we can conclude that we have a right triangle.